Hello, my name is Chia-Ling or Catherine.
And my name is Ya-Chen or Janet.
Our project is Wild Rice from yeast discovery to bread diversity. The inspiration of our experiments is actually started from my personal experience and opportunity to meet and learning a homemade pizza from a master homemade pizza baker. And I learned that his secrets of making the best crust of pizza is using a homemade yeast starter, which the baker I made is using a factory-produced yeast. And I shared this story with Janet, and this actually sparked our curiosity about yeast fermentation. So through our research, we learned that yeast is not necessarily need to be produced from factory. They are actually naturally exist everywhere in the environment, and they are called natural yeast or wild yeast. And this makes us wonder if we can find like a net ideal proportion of yeast water and make it into bread. That way we can possibly use the natural wild yeast to replace factory yeast. Implement to a better to environment, to be eco-friendly and reduce food wasting, because yeast has a natural resistant to mold from our research. And we hope it can help the world and become better.
The aim of our experiment was to find out how pH value and sugar concentration affect the activity of natural yeast, and how that yeast influence the final quality of bread. We start from making yeast water, so we designed our experiment to create different environments for yeast to grow, as shown here.
So how do we decide on our methodology? Our experiment is actually divided into two main stages. In stage 1, we create 12 yeast water mixture samples with all different variables changed to grow and extract natural yeast. Every day, we record the pH levels changed in yeast water and those key signs of fermentation such as air bubbles or smell. We track the pH levels because they reflect the overall condition of the fermentation environment. From what we learned in researching, an ideal yeast fermentation typically causes a gradual decline and then becomes stable in its pH level. And also, understanding the change of pH levels is important because the lower pH levels also contribute to natural mold resistance, typically for those bread fermented from natural yeast. And we observe key signs such as the smell and gases produced because they are the products for yeast anaerobic respiration. From these signs help us to determine the level of yeast activity and how well it's conditioned in each sample. The results of stage 1, we discovered that grapes' performance is stand out from sultana, showing a stronger gas and more distinct smell of alcohol. We infer that the surface of fresh grapes and the environment it provide is more balanced and support an ideal environment for yeast to grow on it. In the example with pH, grapes samples tend to decline lower than sultanas. In terms of the results related to the independent variables of pH levels, we found that the sample with 10% solution of vinegar had weaker sign, fermentation, and fluctuating pH levels. We infer that this is because adding vinegar does not help with creating a more suitable acidic environment for yeast to grow. We infer that yeast can maintain an activity with just the organic acid provided from fruit.
In stage 2, we divided into stage 2A and 2B. In stage 2A, we used the selected yeast water to make bread. To keep the test fair, we used the same amount of yeast water. We then proof the dough twice and measure its growth. Then we bake them into bread. In stage 2B, we measure and record the final quality of bread, including its height, texture, and mold resistance. To test that, we design a molding simulation that simulates extreme humidity, which can identify their mold resistance more obviously. So, what did we find in stage 2? We find that sultana-based yeast water without vinegar performed well in growth, better than those groups fermented from grapes yeast water. We infer this is sultana contains less water, therefore higher sugar concentration than grapes, and supply yeast with more energy resource, so it grows higher. For similar reasons, proportion 3 produced the tallest bread. We infer this is also because its higher sugar concentration. Sustained fermentation they're improving. On the other hand, sample with vinegar also showed poorer growth. This confirms that added acidity will disrupt yeast performance. In the result of molding simulation, bread made with grapes yeast water showed stronger resistance to mold compared to those made with sultanas. This is likely because grape samples tend to maintain a lower pH value, creating a less variable environment for mold growth.
In conclusion, proportion 1 and 2 display the highest yeast activity during fermentation, making them the most optimal for cultivating the ideal environment for wild yeast to grow. But only in stage 1. While they perform best in stage 1, proportion 3 has produced the most bread rice in stage 2, likely due to its higher sugar concentration. We suggest that higher sugar concentration supports longer lasting and steadier fermentation rather than the first initial growth. Because the more sugar supply it is, the longer the yeast are able to consume in respiration with carbon dioxide, and that makes the bread rise. Our data also supports that grapes-based yeast water is more mold resistant than sultana-based, linked to its ability to reach lower pH levels. Finally, the addition of vinegar proved unnecessary and destructive, as natural fruit exits already regulate the pH efficiently from our experiment. So, in reflection, does the experiment completely show what we have expected? Then our answer is no, not fully and not quite. The hypothesis of higher sugar concentration does not provide the most ideal fermentation, but did highlight its importance and successful of making into a higher rice bread. And the 10% vinegar solution method is proven to be useless. And we make the biggest mistake is we are too curious on how so many variables and so keen to understand how they will interact differently through yeast fermentation. But we ending up running out of time. We ending up doesn't have enough of time to repeat our experiments on as many numbers as we can do to possibly minimize the error and extractiveness variables. However, those various results from various variables provide us very well understanding in yeast fermentation from different perspectives. Other mistake we made is we have underestimated the impaction from evaporation. That is, in one of our sample, the initial sample yeast water mixture should be 100 milliliter, but because of the natural environment variables, the evaporation, it is ending up not even half left after stage 1, which makes it very difficult to assess in stage 2. Because to make the experiment fair, we then need to use only that much of little yeast water to make our dough in every single samples, just because of one sample is effects from evaporation. And due to this, the less yeast water has been used to every samples, the less yeast is actually contained, and the actively fermentate in the dough is less. So how we improve is we should mix the mixture with larger mass milliliter. So we definitely have enough yeast water remain after stage 1 that can be used in stage 2. Also, we make another mistake is we equalize the per gram of industrial yeast, which is the control group, to per milliliter of yeast water, but they are not actually equal. The control group ending up very outstanding than all the other groups. This is because we did not realize that a gram of factory yeast is quite a lot that is compressed into a gram, but the yeast water we made at home probably does not contain as much as yeast in per gram.